Welcome students, welcome to this thermal engineering session. This session we are going to see about the steam turbine and condenser. Under this, steam condensers and these are the contents we are going to see in this session. Dalton's law of partial pressure, function and classification of condensers, construction and working of surface condensers, source of air leakage, concept of condenser efficiency, vacuum efficiency, and forced draft, natural draft, and induced draft cooling towers. Dalton's law of partial pressure. The total pressure exerted by mixture of gases or a mixture of gas and vapors, that is, which have no chemical action on each other, is equal to the sum of the partial pressures of the constituents of the mixture if it occupies a volume of mixture at a temperature of mixture. It means, in simple terms, the total pressure in the condenser is the sum of the partial pressure of steam and air. So the pressure of mixture, which is equal to the partial pressure of steam plus partial pressure of air. So according to Dalton's law of total pressure in the condenser case, total pressure P total is equal to partial pressure of steam plus partial pressure of air, where Ps represents the partial pressure of steam and Pa represents the partial pressure of air. So let's see an example illustration. First chamber is having the oxygen with having a pressure of 222.28 millibar, and nitrogen which having the 791.14 millibar, and argon is in 9.42 millibar, and CO2 is in 0.40 millibar, plus other gas is in 0.01 millibar. And according to Dalton law of partial pressure, the full when you come when this full cylinder is comprised of mixture of these things, the final pressure will be equal to 1013.25 millibar. This is the actual pressure of the air, and these are the actual composition of presence in the air. Now let's see the steam condenser. A steam condenser is a closed vessel into which the steam is exhausted and condensed after doing work in an engine, cylinder or turbine. So the steam condenser is used to condense the steam which is exhausted from the turbine after doing the work. A steam condenser has the following two objects. The primary object is to maintain a low pressure, that is below atmospheric pressure, so as to obtain maximum possible energy from steam and thus to secure high efficiency. The secondary object is to supply pure feed water to hot well from where it is pumped back to boiler. The secondary object is to supply pure feed water to the hot well from where it is pumped back to the. Now let's see the classification of steam condenser. The steam condenser may be broadly classified into the following two types, depending upon the way in which the steam is condensed. First is classified into jet condensers or mixing type condensers. Under this, it is classified as parallel flow jet condenser, counter flow jet condenser, barometric or high level jet condenser, and ejector condenser. And the second type is surface condenser or non-mixing type condenser. Under this, there are four types: downflow surface condenser, center flow surface condenser, regenerative surface condenser, and evaporative surface condenser. In our session, we are going to see only the surface condenser. A surface condenser has a great advantage over the jet condenser, as the condensate do not mix up with the cooling water. Here, this condensate does not mix with the cooling water. As a result of this, whole condensate can be reused in the boiler. This type of condenser is essential in ships which can carry only a limited quantity of fresh water for the boilers. The next slide, the figure shows the longitudinal section of the two-pass surface condenser. So this is how the surface condenser looks like. This is the inlet for the exhaust steam from the turbine for the surface condenser, and this is the outlet for the condensate to extraction pump. And this is the shell, and inside this shell some tubes are arranged. This is the tube plate, and this is the baffle plate which separate these two sections. This is the cooling water inlet which goes into the tube, and this is the water box which is undivided. From this, it flows from here and it enters to tubes here, and this cooling water outlet. And the hot steam is enter into this, which is not mixed with these tubes. This hot steam, it flows surrounding this tube, so that the cooling water absorbs the heat from the steam, and while observing the heat, the steam will get condensed and the condensate will come down. Let's see the animation now how the surface condenser is working. When the cooling water is going inlet, it moves through this pipe and it spins this facet and goes to this and goes out. And at the same time, when the exhaust steam from the turbine comes in, it flows through these passages, it surrounds the tubes, and it gets condensate, and the water is coming outlet. The condensate water is coming outlet. So this is how the surface condenser is working. So surface condenser, it consists of a horizontal cast iron cylindrical vessel packed with tubes through which the cooling water flows. The end of the condensers are cut off by vertical perforated types of plates into which water tubes are fixed. So this is done in such a manner that the leakage of water into the center condensing space is prevented. The water tubes pass horizontally through the main condensing space for the steam. The steam enters at the top and is forced to flow downwards over the tubes due to the suction of the extraction pump at the bottom. The cooling water flows in one direction through the lower half of the tubes and returns in opposite direction through the upper half. Now let's come to the source of air leakage. The following are main sources through which the air may enter into the condenser. The dissolved air in the feed water enters into the boiler, which in turn enters into the condenser with exhaust steam. The air leaks into the condenser through various joints due to high vacuum pressure in the condenser. In the case of jet condenser, dissolved air with the injection water. So what is the effect condenser is? Leakage air enters into the condenser. So it reduces vacuum pressure in the condenser. Since air is poor heat conductor, particularly at lower densities, it reduces the rate of heat transmission. So if the air is entering into the condensers, it's slowly reducing the rate of heat transmission. So it requires a larger air pump. Moreover, an increased power is required. Power is required to drive the pump. Now let's see the condenser efficiency. The condenser efficiency may be defined as a ratio of temperature rise of cooling water to the vacuum temperature minus cooling water temperature. This is the condenser efficiency. The temperature rise of cooling water, it is the effect of cooling water. It is the effect of temperature rise. Okay, the temperature rise of cooling water divided by vacuum temperature minus inlet cooling water temperature. This temperature rise of cooling water can be defined as T out minus T in and divided by vacuum temperature minus inlet cooling water temperature. So T out is the outlet temperature of cooling water and T in is the inlet temperature of cooling water. The T vacuum is the vacuum temperature of the condenser. Then comes the vacuum efficiency. The minimum absolute pressure, also called as ideal pressure, at the steam inlet of a condenser is the pressure corresponding to the temperature of the condensed steam. It means the minimum absolute pressure, also called as ideal pressure, at the steam inlet of a condenser is the pressure corresponding to the temperature of the condenser steam. The corresponding vacuum called ideal vacuum is the maximum vacuum that can be obtained in a condensing plant with no air present at the temperature. So the pressure in the actual condenser is greater than the ideal pressure, by an amount equal to the pressure of air present in the condenser. So now comes to the vacuum efficiency. So the ratio of actual vacuum to the ideal vacuum is known as vacuum efficiency. Actual vacuum represents barometric pressure minus actual pressure, and the same ideal vacuum represents barometric pressure minus ideal pressure. Now let's see the cooling tower, how it's working and what are the types. The main applications are in power plants. The cooling tower, the main application are in power plants and refrigeration plants. Its function is to cool the hot water from the condenser by exposing it to the atmospheric air so that the cold water may be used again for the circulation. The cooling towers are used in steam power plants where there is a limited supply of cooling water. So these cooling towers are used where there is a limited supply of cooling water so that we can reuse the same cooling water. So it is placed at a certain height at about 9 meters from the ground level. The hot water falls down in radial spray from a height and the atmospheric air enters from the base of tower. The partial evaporation of water takes place, which reduces the temperature of circulating water. So this cooled water is collected in the pond at the base of the tower and again pumped to the condenser. So when comes to this cooling tower, we are having three types of cooling tower: natural draft cooling tower, forced draft cooling tower, and induced draft cooling tower. Natural draft cooling tower. The circulation of air is produced by the pressure difference of air inside and outside the cooling tower. So in natural draft cooling tower, the circulation of air is produced by the pressure difference of air inside and outside the cooling tower. And the forced draft cooling tower. Here, the circulation of air is produced by means of fans placed at the base of the tower. But in induced draft cooling tower, the circulation of air is provided by means of fans placed at the top of the tower. It means at the exit of the air entry, at the exit of the air. So this is how the natural draft cooling tower looks like. Here we are constructing a long reinforced cooling tower. From condenser, we are sending the hot water through the radial spray. We are spraying the hot water, and the atmospheric air enters into this. It is a helical, hypocycloid structural cooling tower. According to this geometrical structure, the atmospheric and also the pressure difference between inside and outside, the atmospheric air naturally enters into this. So when it enters into this, it absorbs the heat from the hot water so that the hot water and the steam get condensed and it gets cooled and coming down, and again we are sending back to the condenser. Let's see in this video how this natural draft cooling tower is working.
Cooling tower. When we see a nuclear power plant, we can easily distinguish the cooling tower. Cooling tower is the place the coolant medium or water is cooled down for reusing it in the power plant. In this concrete structure, hot water is allowed to cool down, thereby releasing the thermal energy into the environment. The cooling tower can be up to 200 meter tall. There are two types of cooling towers. One is cross-flow type and the other is counterflow type. Before moving on to the working of a cooling tower, let us look at the components of a counterflow type cooling tower. A counterflow type of tower has cold water basin, air inlet, fill media, spray nozzles and drift eliminator. Hot water is pumped into spray nozzles. Due to the natural convection, cold air gets drawn from outside through air inlet. The cold air then cools down the water which is stored at the very basement of the tower. Note that during this process about 2% of water evaporates. A cooling tower works on the principle of natural circulation. Due to the difference in density, the warm air rises up and escapes from the opening at the top of the tower. Now, let's understand the components and working of a cross-flow type cooling tower. This type of cooling tower has drift eliminators, distribution system, fill media, and exhaust fan. In case of a cross-flow cooling tower, hot water is sent through a water inlet to the cooling tower. Then, it is distributed on the fill media through water distribution system. The gravity causes the water to cascade down across the fill media. The fill media breaks the water stream into smaller water droplets, creating a large surface area for heat transfer. The exhaust fan installed at the top draws air across the water droplets, and cooling by exchange of latent heat results in the form of evaporation of a small amount of water. After passing through the fill media, the water gets collected in the basin. From the basin, it is pumped back to the chiller condenser section by the condenser water pump. Difference between cross-flow type and counterflow type cooling towers. The discussion will remain incomplete until we discuss about the difference between these two types of cooling tower. In cross-flow type cooling tower, airflow is directed perpendicular to the water flow, whereas in counterflow type cooling tower, airflow is directly opposite of the water flow. Alright, now that you have understood the working of a cooling tower in nuclear power plants, can you explain it to your friends? Recap. In this lesson, you learnt about different types of cooling towers, their components, and the working principle.
Now let's come to the post-water cooling tower. So in this post-water cooling tower, you can see is the fan is kept in the lowermost bottommost part of the cooling tower. So here the air is pushed from the bottommost part. From this air, the hot water from the heat exchanger that's from the condensers which comes here during the spraying out from the top. So when this air is forced from the bottom of the forced air enters into this tower, cooling tower, so that while going through this, it absorbs the heat from this hot water, so that the water gets chilled down and it settles down and it again go back to the heat exchanger or condensers. So this is what how the post water cooling tower is working. Let's see the animation of how the post water cooling tower is working. When the fan is rotating, it forces the air to move from bottom to the top. So when the air is moved from bottom to top, at the same time, the water is sprayed from the hot water from the heat exchanger or condenser sprayed from the top. It's moving coming down. At the same time, the heat exchange is happening inside this region. The air absorbs the heat from this hot water and it leaves out to the atmosphere. And at the same time, the chilled air is coming down and collected in the basin and it's again pumped to the heat exchanger. Now let's see the induced draft cooling tower. So in this induced draft cooling tower, we are induced the air by keeping the fan in the top of the cooling tower. Now here, the same principle compared to the post draft, the water is hot water from the condenser is sprayed from the top, and in induced draft, the air from the bottom it is induced inside by running the fan in the top. So this air it absorbs the heat from the spray, from the hot water spray, so that the water get rejected the heat to the air, the hot air comes going out, and the chilled chilled cooling water is coming down, it's collected in the basin and it's again circulated to the condenser. fan is running, the hot water, the air from the atmosphere, the air from the surrounding, it's enter into the tower, and at the same time, the spray, when the hot water is sprayed from the nozzle, this air, while going up, it absorbs the heat from the hot water so that the hot water air out and the chilled cooling water is coming back to the basin and collected and it's again used for the condenser purpose. Thank you, students. Thank you for watching this session. Let's see you in the next class.